Now let's take a look at a few basic Ethernet standards for our local area network. Traditional Ethernet standards included 10-base-2, 10-base-5, and 10-base-T. Particularly 10-base-2 and 10-base-5, we want to take a look at the naming here. 10 indicates the bandwidth or megabits per second. Base is baseband signaling. That's your signaling. And then right here, we'll throw in the 5. 5 is 500 meters. 500 meters cable length before attenuation would degrade the signal. So therefore, you would need a repeater every 500 meters when using 10-base-5. Whereas 10-base-2, this is actually not 200, but instead it's 185. It's 185 rounded to 2. So every 185 meters you would need a repeater. 10-base-T, 10, once again, still the same megabits per second, base for signaling. T for twisted pair. Twisted pair cable also has an attenuation. It would be 100 meters, whether it's the 10-base-T or 100-base-T, and we'll talk about those here in just a moment. Another topic or concept to remember with Ethernet is that of carrier sense multiple access with collision detection. This is the method that's being used on hubs, making it possible for the different devices to communicate with one another over Ethernet. This is what's called the access method for this contention media. This is where you've got multiple devices attached to this hub, and only one device can communicate at any given time. If more than one of these PCs attempt to communicate at the same time, there would be what's called a collision. A collision occurs when you've got two of these devices trying to transmit at the same time. What happens is when a collision occurs, both devices back off. One device backs off a little further than the other, and then the first device goes ahead and attempts to transmit again, and then the second device goes ahead and goes. Problem is, sometimes when that second transmission takes place, one of the other devices in the environment also attempts to transmit, and you might have another collision, thus reducing the overall speed of the network. Excessive collisions affects network traffic in a negative way by slowing the network down. Hubs use carrier sense. They sense the carrier, multiple access, there are multiple devices accessing the network, with collision detection. In other words, hubs can detect a collision, but they can't avoid a collision. In other words, we can call the police after there's an accident, but we can't avoid the accident with a stoplight. That's the hub's mechanism for this contention media, for extending the Ethernet architecture. Then we've got the addressing for Ethernet. This is done with MAC addresses. MAC addresses are made up of 48 bits, and there are two portions to the MAC address. There's the OUI, or Organizationally Unique Identifier. That's the first portion of the MAC address. And then there's the vendor assigned portion of the MAC address that would accommodate the 48 bits. Framing, Ethernet framing. Framing is a method for actually organizing the bits that would be transmitted from one device to another, so that when the bits are being transmitted across this media and received by this other device, the other device has a way of reorganizing those bits, or a standard or a protocol for reorganizing those bits so that they can be understood, and that's called framing. Inside the Ethernet frame, which Ethernet uses 802.3 as its standard for framing, inside that Ethernet frame would be a source address, source MAC address, and a destination MAC address, along with other parameters, including the data itself. And all of that is a result of the framing method that's being used with Ethernet. I mentioned that these are a couple of your previous or traditional standards for Ethernet right here. 10-base-2 was thin net, and then 10-base-5 was thick net. These are not being used often anymore in existing network environments, whereas 10-base-T is still being used. But these are pretty much all being replaced by newer methods, including fast Ethernet, which is 100 base T, and then there's gigabit Ethernet, which is 1,000 megabits per second. So that gives us a basic look at a few of our Ethernet concepts for our local area network.
In this example, computer 1 has a message to send on the network. It begins by listening to the wire to determine if it is being used. When the wire is free, the computer sends the message. Now suppose that computer 2 and computer 3 both have a message to send. They both listen to the wire, determine that it is free, and begin transmitting. Because they were sent at the same time, the messages collide. Both computers detect the collision and transmit a jam signal. Each computer then waits a random amount of time, listens to determine that the network is free, and resends the original message.